Welcome to Compound Growth or Loss Part 2. And I'm starting off with a finance kind of example here. So, we are investing $5,000 and we're getting 3% compounded daily. How much money do we end up with after 10 years? Now, I'll explain what this compounded daily means as I fill in the formula. So we start off with that's what we're looking for, the final amount. We know we're starting off with an investment of $5,000. That's our starting quantity, and we're going to times that by. And this time it's not doubling or tripling or anything like that. We're getting a percentage, so it's going to be 1. In this case, it's growing, hopefully, plus. So 1 plus, now I got to put in my percentage. Now here's where you got to be careful. When they say it's compounded daily, it means they calculate how much money your investment has grown by every day. And then they add that quantity of growth to the amount of money that's been invested. And so they're basically doing these calculations every day. But you're not getting 3% every day. This 3% means for the year. Often you'll see they'll say 3% per annum, and if you see that, all it means is that's Latin for per year. So you're getting the 3%, that's an annual percent growth, but they're compounding it every day. So what does that mean I put in here? Okay, well, what it means is, yes, it's 3%, which is 0.03 in decimal form, but you got to divide that now because they're doing this every day, but you don't get 3% every day. You get 3% divided up by 365 days. Okay, so you've got to tweak your percentage of growth. What you're basically doing is saying I'm getting this fraction, one day's worth of 3% is what I'm getting. So it's your 3%, 0.03, divided by 365 because we're doing this every day. And then the exponent here, okay, it's 10 years of growth. So you go, yeah, that's good, that's 10, but wait, if we're doing this every day, the number of growth periods should be 10 times 365, okay? So this is how many growth periods your money is going through. Basically how many mathematical calculations are happening. And each day, that is the amount of growth you're getting. Well, that's the difficult part. Once you have that all done, it's really easy. You just make sure you're careful when you put it through your calculator. So at the end of those 10 years, that $5,000 has grown into $6,749.21. Okay, so that's kind of how finance works. And what I'd like to do is just set up. I won't bother actually working it out, but I want to set up what would it look like if it was, say, monthly. So in this example, let's say we were going to invest $2,000. And we're going to do that maybe for, let's say 15 years. And the bank says you're going to get 3.5% per annum. Okay, so per year. And they're going to compound it. Oops, let's clean that up a bit. Compound it. Let's do this one monthly. So I won't work this one out. But how would I set this up in my formula? Well, it would look like this. Final amount equals my starting amount, or principal, as it's often called in finance, the principal amount. So 2,000 times, and then in brackets, 1 plus. So now I got to take this 3.5% as a decimal, so 0.035, but we're doing these calculations monthly. So you're getting 3.5%. You got to divide that up by 12 months. Okay? And how many calculations are we doing? This is over 15 years, and we're doing these calculations every month, so I've got to times that by 12 to get the correct number of growth periods. So this is what I would put into the calculator and figure out how my money has grown. But well, I'm not going to do that right now. I'm going to move on to radioactive decay. So in this final example that I'm doing, we have a radioactive substance. Now, if you don't know what radioactive decay is, radioactive substance, I'll explain it. The best way to think of it is if you have a hot pan on the stove, and so you can think of it as being very radioactive. It gives off a lot of heat. In fact, the moment you turn the stove off, it's giving off 100% of its radiation or heat. And what we call a half-life is how long in time, like how is it minutes or seconds or years or whatever, how long does it take until it's half as hot? And that's what we call a half-life. So suppose we have a radioactive substance and it has a half-life, okay, a half-life of 17.5 hours. So what that means is every 17.5 hours, it's lost half of its radiation, or it's kind of like it's half as hot as it used to be. So now comes the question, what percent remains? So what percent remains after 3 days? After 3 days. All right, so now we got to set it up in the formula. So we're looking for the final amount, which in this case is now a percentage. And that's going to equal our starting percentage. Well, initially with these half-life problems, we like to consider it as 100% of the heat, or 100% radioactive. And then I'm going to have times in brackets. Now, this time it's not a percentage that you lose. It just is a half. So you can put in 0.5 or 1/2 if you like. It's kind of like those doubling or tripling type questions. But this time it's half as much. Every time it goes through a growth or a loss cycle, you've got half as much. All right, now the tricky part of this one is what do you put in for your exponent? So how many growth cycles, or in this case loss cycles, are we going to go through? Well, the trick is first figure out 3 days in hours. So I'm going to go 3 times 24. Okay, so that's how many hours the stuff has been sitting there cooling. So there's my total number of hours, and what I'm now going to do is divide that by how long it takes for it to do one half-life, which is 17.5. So that's going to be my correct number of loss periods here. I take my total number of hours and I divide by how big each half-life is. And then I know it's however many that is. I really don't know. But that tells me how many of these loss cycles we've gone through. And again, once you've done that, the hard part is done, because now you just grab your calculator and you put everything into the calculator. So I ended up with 5.77%, and that's what's left. So it's cooled by quite a bit. All right, I think that's where we're going to stop for this, this lesson. We'll catch you later.